Hey everyone, welcome to the Rapid Reflections podcast. This is our first official episode, I guess, and we wanted to try something new and sort of try different formats with talking different groups of people. So today we have just me and Radee. We want to have a specific talk about our undergrad experience, and maybe next episode you'll see Tom and we'll have a special guest. So how have you been, Radee?
Not too bad, Wesley. How are you?
Yeah, pretty good. I guess, we're here to talk about some undergrad.
That's right. Where should we start? Where we are now or the very beginning?
I guess we should...
it makes sense chronologically, I guess, to start from prior.
Right at the beginning?
Yeah.
So I think maybe, how do you want to do this? We can go from the start. We can talk about our courses, how we feel about them, I guess, when we were studying, and then sort of some hindsight, how we feel about it now, like looking back.
So what do you reckon, before even that, maybe what your preconceptions even coming into let's say year 12, end of high school, Wesley, what was going through his head? What did he expect coming into uni?
Yeah, so I think, we did talk about this sort of in the first, the episode 0, how we were sort of pretty keen on studying physics and maths. Wow, this is really cool. In uni, this is where we all learn the cool stuff, this Newtonian stuff, but we get into graduate mechanics, the quantum mechanics, quantum physics, superposition. You get to learn about all this stuff. I think going into uni, I was pretty keen. I was very excited for sure.
Yep.
I think I can speak for both of us. As we got through the uni years, our sadness grew and the excitement declined.
That's right. We'll definitely get to that, but I definitely was pretty much in the same boat.
Yeah.
Before uni, definitely super hyped to get in there and learn about all those cool things every pop sci book on the planet has ever talked about.
Yeah.
So all right. So how about first coming into uni then? How should we go? Maybe we should just talk about first year maths and maybe first year physics.
Yeah,
that's probably a sensible place to start. Yeah.
I think we both took some random electives, but that's
kind of
not that important.
Yeah. And I didn't quite enjoy them. They're not even worth talking about, to be honest.
So I guess we'll say focus on physics and maths this episode. First year maths, that was not very fun at all, to be honest. First of all, there were 9 a.m. lectures every week for 4 days out of
4 days
5.
a week, that's right.
So, and not only that, it was early lectures. I felt like a lot of them was a rehash of what we did in year 12.
I was about to say the same thing, yeah.
Felt pretty unnecessary.
Especially in first semester. First semester was pretty much year 12 high school
calculus,
all over again.
You learn everything again. Maybe the notation looks a bit more formal, but I
think that was better. It was just, you were a bit more strict, let's say, quote unquote strict with your notation, but even still, that was pretty much it.
Mm-hmm. Yeah, first year maths was not very memorable, to be honest. What were some cool takeaways? I think linear algebra was sort of the new topic that we learned about.
That's right.
We did more with linear algebra.
That's right.
And we just matrices are not just shopping lists and you add stuff up, you sum, you total sum.
That's right.
It seemed a bit more useful. There are a few more interesting things in there, I guess. But I think even then it just sort of seemed like we didn't really know why we were doing any of it. It's just learn this procedure,
brute force calculation kind of thing.
Learn some Gauss-Jordan, learn how to do eigenvalues. But it didn't really make sense as to why we need any of this.
That's right. Yeah, there was no broader context for what's the point.
Oh, and do you remember doing Gram-Schmidt?
Gram-Schmidt.
What is that? It's great. We just learn the procedure and then you regurgitate it back in the exam and it's all good.
That's it.
I guess there was not much motivation, I guess, as to why we're doing that stuff.
Why those kinds of things are important, yeah. No, I completely agree, actually. You put that quite nicely. I think, my takeaways, I would probably say the same thing. Linear algebra, and specifically in the second half of the year. The first half of the year was pretty much Gauss-Jordan elimination. We did that thing to absolute death. To my goodness me. That was too much to handle.
We just doing matrix to another one.
Okay. What about physics in that case?
Physics? Physics. I think I struggled a bit, doing a transition from high school physics to uni physics.
That was a big jump.
I think I definitely struggled doing the transition. I remember our first few physics tutes, we were pretty strict on coordinate systems, I think. Because set up your coordinate system. We're doing like in vector notation now,
That's
rather
right.
than like just you have all these scalar quantities, but now they're all actually vectors now.
That's right.
And you're like, oh, like what's the difference? But like you're trying to like draw the diagram. It was a bit more confusing.
Yeah,
but
I think I didn't find that was motivated particularly well as well. Like
not
the
really.
transition, like why it's so critical.
Yeah.
Like, of course, in hindsight, you learn it's pretty
Yeah.
critical. But when you're there,
Yeah.
it's kind of like it just adds confusion. You're like, why are we doing this extra notational business? And it kind of covers up the physics happening. Yeah.
Yeah, I definitely didn't appreciate like F equals MA. In high school, there's just 3 letters. F, M,
That's
A.
right.
You plug in 3 numbers. You plug in 2, you find the other
that's
one.
all right. That's the over question.
Yeah.
Given 2, find the other. That's pretty much all of high school physics.
But then in uni, it's like, well, no, that you can't just do that. They're not scalars, and you're like, oh wait, why not? And then sort of things have become more clearer. But I guess in first year, it wasn't like really explained as to like that jump.
That's right.
Yeah,
I found also one thing which was, I guess for some people might be good, but I didn't particularly like, was how there was like that whole smorgasbord of subjects. You did a bit of waves, a bit of EM, a bit of classical physics, a bit of modern physics. It was all just like these little
tidbits of
4-week modules of nothing. But they all just like slammed them on you.
Yeah, and like they were pretty fast paced. Like they just like, oh, here's the content. Like we're gonna dump it all at you.
That's right.
Just like learn whatever you can, and
That's
then,
right.
like, half the stuff you're not even gonna care about until like really later on. It's like what? I guess looking back, it was like sort of a waste of time. Like we didn't really get time to delve deep into say like even just like classical mechanics and like learn it properly.
Just the that's right. I even found, let's say, even in second semester when we had our second mechanics course.
Yep.
Right, we
did rotational mechanics.
Rotational mechanics. I think I was like underprepared for that.
I was so bad.
Whatever we did in first year, like the first semester rather, like didn't link
didn't
to that
translate
well.
at all.
No,
Yeah.
I was like, that was brutal. I mean, I think most people had a hard time with that, but that was.
Yeah. I think that in-class test. Oh, and those horrible physics in-class tests, like 15 minutes or something.
15-minute tests.
15-minute tests.
That's right.
They're worth like 10, 15 minutes or something.
That's right.
Wow, like what a way to assess the course.
1 minute, 1% of your grade. Like, my goodness.
Like if you're like slightly under pressure.
And that rotational mechanics test, I think I like butchered that.
I butchered that.
I'm like, we're done for. Like, my career's over.
Well, luckily they sort of scale it so they give you the best grade, but still, I think like those sort of assessments just like really didn't help.
No,
like they stress you out.
Just stress
for no reason.
Another good thing I guess we should talk about if we're talking about stress is like the practicals. Because it's like it would be like 3 minutes of like pure cram doing the most menial like task ever. Like our first practical, if I remember correctly, was literally like measuring the volume of brass.
Because it was like uncertainties.
That's right. Yeah, you're getting learning how to use like uncertainties, calculating with them, etc. But geez, it's just like you're doing such a boring task, but you have to do it in such short time and write up the whole report, etc.
Yeah. So maybe if for people who don't know, sort of like we. In physics first year, maybe even for chem and bio, I'm not sure how that works. I think all the science courses.
Sure. I expect most science courses would have theory and practical components.
So usually what happens, we have like a prac class, and it was like 3 hours in first year.
That's
every week.
That's right.
Yeah, and basically
every second week, was it? I can't remember.
I don't remember. No. Yeah, maybe it was every second week.
Yeah.
But anyway, you rock up and you get, they brief you on like, what the prac is today. So you have to like listen to all of that, take that all in, get that all understood. And then you carry out the prac with a group of like, maybe you're in a group of 3.
That's right.
So you carry the prac out and then you do the measurements, do the recording, do the calculations, do the analysis, write up the whole prac report in that 3-hour frame.
That's right.
And then you hand it up before you go home.
That's right.
So that was always a stressful time. I think it was like...
I practically always remember coming out of that thing with a headache, like virtually every time.
Because like the last half an hour or so, it's like you're just like non-stop. You're just writing as fast as you can. Like,
That's right.
How neat you write.
And like just comparing that with high school was like, man, I'm not used to this. I wasn't ready for that.
Yeah, like high school, you had like 4 weeks to do it, like write up the prac report and do it. Like you had all the
That's
time.
right. Yeah.
You get drafted.
Yeah, you had all that. That's right.
Yeah, and then you think like, how is this ever useful? Like in no world you're gonna do all of this in one sitting. Like how. You can expect a scientist to carry the prac out, write everything up, do the analysis.
Yeah, especially I think it's I wouldn't mind if they just asked for like lab notes.
Lab notes, yeah.
Which is what we did in second year. We'll get to that, but that's much better because you don't have to do this whole discussion, aim, like all the year 12 stuff.
Yeah, just
but
imagine
like
writing a year 12 prac in 3 hours.
That's right.
Plus, we have to do the experiment as well. Like,
That's right.
What is the point?
That's right. Yeah. No, I didn't get much out of that myself. It was,
It's just sad.
just headaches. Yeah. That was all I remember.
Mm-hmm. That was
and coming out of there like sweating.
Yeah, like your hand's still shaking. You're like writing really fast.
I think that was and I think the other thing to note, and I guess with lectures, I didn't find. Yeah, I was expecting higher quality as well. My preconception, if you wish, coming in to university was that like the material would be like crisp, well explained. Everybody cares about what they're talking about, but then you get some sad physics lecturer who's like monotone and doesn't want to be there, and you can see it, and you're bored in every single lecture. That was the one I remember specifically for waves second semester. That was and also modern physics as well. The special relativity.
That was not good.
Oh my goodness me!
Yeah, it was definitely sad. And when you had to like rock up and just sit there and listen to boring things and be bored by something that's supposedly so interesting, it just really demotivates you. Like you just feel pretty deflated.
It's purely deflationary. It's like because you had such grand expectations.
You're like, wow, this is gonna be so cool.
The best thing.
Then you hear someone like sitting like at the front, and just like the most boring thing you've ever heard. It's
That's
like,
right.
Wow.
Yeah, and also I guess. Was there a fair bit of overlap? Actually, no. I think the only overlap we had was with the modern physics, because that
was just a rehash of like year 12.
Year 12, because all of that's in year 12 now. So I guess that was like just a pretty much waste of time.
Yeah,
and it was delivered in an uninspired way. Also,
Maybe there was like one new derivation of like the p squared c squared
sure.
c squared c4 thing.
Yep.
But I mean,
virtually
didn't mean anything to me first year.
So that was first year. And so I guess second year, this is where it becomes more interesting and more sad.
Mm-hmm. I guess, but even like after first year, I was like, oh, okay, this is just first year, I have all this stuff to look forward to,
exactly right.
It's still okay.
When I was looking for the syllabi for like all of the is that correct? Syllabi probably, all the syllabi for the second semester courses. I was like, man, what do we have? Like classical mechanics, electromagnetism, quantum mechanics, all the like big pillars, right? So I was,
even after first year, although it was pretty like non-interesting.
It was pretty meh.
I was like, oh, okay, second year, something I can look forward to.
Yep.
I guess something actually I should probably mention is we did coding in first year actually before we move on to second year.
Oh, you did in each semester too? Yeah, that's right.
We did coding. I think we had quite different coding experiences, but I guess, I guess I'll start. So
sure,
I had done no coding whatsoever prior to coming to uni. It seems stupid, but I guess no one really told me. Like, people who do maths and physics these days are not writing on paper anymore. So you have to know how to code. But I guess it never really occurred to me. So then
that in my high school career was never mentioned once.
I've never heard
not once.
I've never heard anyone talk to me. It's like, oh, you like maths and physics? You should do some coding. Like, no one ever said that to me.
Yeah.
And then when I came to uni, I'm like, oh, that makes sense. I'm kind of screwed now.
That's right.
Because I had to learn from scratch. I guess the intro course was like not bad. It was like it was okay. It was gentle.
It was gentle. Yeah.
We were like drawing pictures using JavaScript.
That's right. Yeah, virtually that was.
And then we got to like animations by the end. But then we did object-oriented programming in second semester.
Yeah.
And what a course! That was probably like still one of the hardest courses I've done. Like relative to how I was feeling that at that time.
Yeah.
Reflected in my grade as well.
You freaking struggled big time with that. It was definitely like, one thing to mention with that course, the lectures were practically useless.
Yep.
Like the lectures, was it 2 a week or 1 a week? I think it was 2 a week.
It was
Monday and Friday maybe.
2 a week, yeah.
Yeah, 2 a week.
Yep.
But they were
so
completely useless for the actual coding part of the course.
They taught you nothing about coding. It taught you about computers and how like memory works.
That's right. How the CPU processes, memory blocks.
But I mean, when it comes to actual coding, like it really teaches you nothing, and really the whole course is just you struggling just working it out and like compiling stuff, and nothing works, and you're like, what is going on?
That's
like,
right.
And then imagine you were like drawing pictures, like really happy, you know, having animations,
From
nice things,
semester.
and then you're like doing object-oriented programming. You're like, where is this like?
Just
pointing?
like on the command, the whatever it's called,
on the shell script, whatever.
Yeah,
something like that.
Yeah.
And you have to you learn about classes, you learn about libraries and stuff like.
That's right.
That was
like
rough.
Completely different to the first semester. Yeah.
Completely different. So.
Yeah. I think in my case the warm up for that wasn't too bad because like I think in year 11, end of year 11 or something, my dad taught me a bit of C. So coming to C++ wasn't terrible.
Yep.
I didn't get completely blown away, and I kind of liked the do-it-yourself kind of approach because I mean that's how you learn programming. You just got to do it. Yeah. But I guess if you're not used to that and you're doing it, you're just sitting there like, what the hell is going on? Yeah. But yeah, with that little bit of experience, that definitely helped me get through the course. Yeah.
For sure.
So that's good that you brought that up though. Yeah, I actually kind of forgot about that.
Yeah. For anyone who's like doing physics or maths in high school and like
even in biology, like I have a friend studying medicine and he has to do a bit of R. Like he's coding in R.
Yeah, R is like super important. I think even in psychology, I mean, you're looking at statistics, right?
Like your brother, does he have to do that kind of thing?
He learned a bit of R in his...
Sure. That's what I mean. Like, geez, if you're just working in, let's say, modern science / mathematics, any coding experience is recommended.
It's like so valuable. Like it's actually, that's probably one of my
definitely in physics and math. Like
for sure.
Definitely in physics and math. Yeah.
Like no matter what you're doing, like don't think, I'm a theoretical physicist. I'm going to be writing on a blackboard and solving.
That's what I
thought. Okay, but like
just like pure brainstorming all day long. Yeah, no, you're not doing that.
It's not
anymore. Maybe like 200 years ago.
Yeah. So like that's not how it works. So yeah, I guess that would be one of my like number one advice. Is like if you are interested in like any STEM field, I think any part of STEM, just like learn some coding. Like be comfortable with using a computer and like knowing how a computer operates. Like,
even on just like
surface level.
Surface level, it just definitely helps so you don't get like completely baffled when you first come.
It's like definitely a different way of thinking because you use your computer every day. You like click on stuff. That's right. You don't really think about what happens. It's not like you go, find this and then it actually like understands what you said. Like something actually happens. So
that's right.
That type of thinking is a bit.
It really, you kind of have to break it down. Yeah. Like you have to. If you're going to solve a problem, you have to basically break it into like the tiniest little steps that you do piece by piece. Yeah.
Something like a computer would understand.
That's right. Yeah. That definitely, if you're not used to it, geez, you get rocked. Rocked hard.
It's actually hard. Yeah. I guess, that was mostly first year. I guess, moving to second year, we were still like pretty keen,
Keen,
What did we take in first semester?
So first semester we had a quantum mechanics course, or like a sole quantum mechanics course, which was like, you do the basics like infinite square well, finite square well. Do you do oscillator? You do quantum harmonic oscillator in there. You do, just like the you get introduced to the Schrodinger equation finally. Like, pretty much that's it. And then you just do that for the whole thing.
Yeah, that's literally all we did. Finite square well, infinite square well, harmonic oscillator.
There was, you also did the tunneling, like it comes across a step potential. And when it tunnels through, whatever, like there's a spike and then the incoming free particle, whatever.
I
passes through.
Vaguely remember.
And then when the other one we did, I think, was when there's like a potential barrier, it comes in, and then if it's a higher potential, it starts decaying. It gets the exponential, but that's pretty much all we did. It was what else did we take? We took. We took three maths courses. We took abstract algebra, like introductory abstract algebra, a DE's course, and a multivariable calculus course.
Yeah. Oh wow, that was a lot of maths actually.
A lot of maths in that semester, yeah. So,
how was that for you?
I didn't mind it. That's kind of when I started realizing that I was into math, like properly. Yeah. So that semester was one of the best ones I've had.
Right.
Yeah, I think. Yeah, that first semester. That would probably be one of my best semesters so far, I'd say.
Yeah, I actually think so too.
Because the multivariable course it wasn't proofy or anything, but it was hands-on. But I was like excited to learn, line integrals, volume integrals.
Triple integrals.
Yeah, doing all these nice solving all these big equations that I thought would be, pretty cool to do. Yeah. So coming across them, I was like, oh, that's actually pretty cool. And what else did you do? Gauss theorem, Stokes theorem.
Which is
divergence is Gauss. Yeah, that's right.
Was there another one? Or the fundamental theorem of like vector calculus?
That's right. Which is like, basically,
Basically.
you just change like the derivative to a gradient, but same thing. Yeah.
And we did index notation actually. I really
Index
liked
notation. That's right.
index notation.
That's a must. Anybody doing maths and physics, index notation helps, but particularly physics. Yeah. So that was a good course. Abstract algebra, that was the best course.
That was the best course.
My,
that was pretty life-changing.
Completely, like, my expectations of what, let's say, maths was, like real maths, let's say pure maths, was
I
like,
was mind-blown.
Not that. When I got there and I saw what we're actually doing, I was like, in shock.
Yeah, I was completely in shock. Yeah,
but in shock in a good way. I'm not like, I was like, wow, this is legit.
I was like, wow,
I wasn't expecting this.
Really cool. Yeah. Although it was a freaking hard course. But,
that was it was brutal. The assignments were
literally impossible. Especially we were doing them online. It was COVID.
Oh yeah, that's another important thing to remember.
Anyone.
Yeah, that was the beginning of all the COVID shenanigans. Yeah, like I think all of our class after the second week went online full.
Yeah, and then the whole year was basically online.
The rest of that year was online. Yeah,
that was so rough actually.
But yeah, nonetheless, that course was a good course.
Yeah, Algebra 2 was really good. It really opened my eyes. Like, I was like, wow, like maths is not just a tool. Like, it's something you study. Like,
there's actually a lot to dig into, and like, you just don't see how deep it runs if you just like use it as a, I'm just going to do some calculations with it.
Yeah, like I think we started off with group theory, and I think was it the first lecture? He's like, oh, this is a group. Shows you the group axioms. I'm like, what is he doing? This is like dumb stuff. This is trivial. What are you doing? And then you like work more with it. You're like, wait, this is like really cool. Like,
that's right. Yeah.
So many things are like, you can work with them like abstractly, and you see, oh wow, there's like similar structures everywhere.
That's right.
And you take a lot of things for granted, I guess, when you're working with like real numbers and stuff. But I guess when you abstract that away, you're like, oh, you just have some sort of structure, and that
you can only use that's exactly right. The rules that
and then what you're left with are the axioms. You're like, wow, which genius thought of this? Like, this is really cool.
Yeah. That group theory, I quite liked it. The second. I didn't find that as hard as the abstract linear algebra.
The linear algebra was so hard.
That was very difficult. I think the thing that kind of got me, what was it? The thing that kind of like, when you start talking about dual spaces, Jordan canonical form, and I was like, that was definitely tricky
dual
stuff.
Spaces in, that was,
Yeah, the transpose linear map, whatever. Yeah, that was...
I was not ready for that.
I was not ready. That was definitely a lot to swallow.
Like, imagine going from first year where you were like working with matrices with like, real number entries, and you're like doing Gauss-Jordan. You're like, wow, this is lovely. I love linear algebra.
That's right.
And then you like, boom, second year, it's all abstract.
That's right.
You talk about linear maps, and you have some dual space. You're like sending things somewhere else, and you're like,
oh, and then your expectation of what a vector is gets blown out the water. That's the other thing. Like,
what's a vector?
Everybody in like high school, even first year, is like, a vector is a magnitude direction. You can write it as an arrow. Like, no, this is not what a vector is. It's a thing that sits inside of a space which satisfies how many 8 axioms or however many axioms there are. That's what it is.
It's like, jeez, it's like the expectation.
Yeah. So when you start talking about like polynomials as vectors, I was like, this is possible, sure, yeah, like
that was so confusing.
Yeah. It was, but that was definitely what's the word? I guess eye-opening.
Eye-opening for sure.
That course.
Yeah, that definitely was like, wow, I really love algebra.
And the D's course wasn't terrible.
It's not terrible.
Wasn't that good either.
Yeah,
I think
I feel like
it had good moments. Like we solved a few D's. I think we solved the D. What was that D called? The one that gives you the polynomials, the Legendre polynomial. Is that Legendre's ODE? Probably is called that. Yeah. Anyway, I'm like solving that. I'm like, oh, that's pretty cool. Like, it's cool to see where that thing came from. Yeah. There was a few, and the gamma function, I think, or the Bessel's function. They came up in there, and I'm like, it's actually not too bad. Yeah. So that was, my hopes were still relatively high then.
Yeah, I think that because that semester was particularly good. So I think
that was a good semester.
It sort of like raised our
that physics course was much better than the two ones in first year.
Yeah.
For sure. That quantum mechanics course.
But I think looking back now, I think it was because it was like just maths, really. You're really doing
Yeah.
maths with some sort of physical.
And you
physics
also
context.
you got to see QM in like
maths
the raw form,
Yeah.
right? Like what it actually is. You're solving a
Schrodinger's
DE
equation.
in for different potentials.
different, yeah.
That's right. There's none of this
Different
like
conditions,
magic talk that you usually get when
It's
people
no cat
talk.
in a box.
That's right.
Yeah, none of that. You're actually just doing the maths, you're solving it, you get some answer, you're like, great, this is what
That's
it
right.
means.
Yeah, you get a real taste for what QM actually is.
Yeah.
Yeah. So for that, yeah, it was definitely good.
Yeah, first semester was.
I think I learned a lot in first semester actually,
Yeah.
like lots of different things. So overall, that was pretty good. Yeah.
Yeah, and it was pretty wide ranging as well because we did from vector calculus to like abstract algebra to like differential equations.
Physics.
and,
That's right.
like,
Yeah.
that's
It was
literally, like,
actually it
everything.
covered
We,
lots of
touched a lot
ground.
things.
Yeah.
Yeah. That was good.
Yeah.
And then moving into second semester, probably one of the worst semesters I think we've had.
Yeah, I think.
comparable to like third year first semester, I think.
Yeah. What third year first semester? What do we have? There?
We had topology.
Yeah, that
was
that
good.
kept it high. We'll get to that in a second, but yeah.
Yeah.
I think second semester was the worst semester so
That was
far.
pretty bad.
The one we're in now is
Also,
is not that good either. I tell you, but that was the low,
Yeah,
low.
yeah.
Yeah.
we reached a minimum, definitely.
Yeah. So what did we take? We took a course in electromagnetism.
Mhm.
We took a course in classical mechanics.
Yep.
We took a course in
Real analysis.
and we took a course in
Some sort of numerical.
like a numerical methods course.
Yeah.
Yeah. That's right. So we'll start with the best one, real analysis.
Mhm.
Naturally, that was also. I had heard about that already, so I kind of knew what to expect.
Mhm.
I hadn't heard anything about groups coming
Yeah.
into that. Like I heard the name, but nothing whatsoever
Yeah.
about what you actually do with them.
Yeah.
But real analysis, I was like, had a rough idea about what to expect. So I wasn't, let's say, as blown away.
Yeah.
But I still found that course pretty cool.
Yeah.
Yeah, it
For
was
sure.
definitely a good
I
course.
think that was the same for me. I don't think I heard much about real analysis coming in. I mean, I know it's a course that sort of builds up to calculus, but I don't even
That's
know what
right.
that means. It's like,
That's right.
what do you do? Like, you know, you just prove the fundamental theory of calculus again? It's like, what's so different? You know, you're like,
That's
I've
right,
seen
yeah.
the proof. Like, what's
Yeah, but I guess for anybody who doesn't know, it's kind of you just start with like some bare bones axioms about the real numbers, and then work your way up to the fundamental
Yeah.
theorem of calculus, and it's step by step. You're not taking any shortcuts whatsoever. So every week we were just getting that one step closer
Yeah.
to building up to the main results.
Yeah.
And I thought that process was it was pretty digestible actually.
It was digestible.
Yeah,
I
like-
liked the lecture videos, even though they were like not in person anymore. We had like little bite-sized
Bite-sized,
lecture videos
yeah,
for
yeah.
like little topics.
Yep.
Yeah, I definitely think I understood a lot of things, but you can see how hard it really gets when you like do the true questions or like, you do some exam questions. Like
That's
you
right.
look in the exercise book even.
That's right.
Like
Yeah.
the questions get really hard. Like I felt like I learned all the concepts like pretty well, but when you like try to apply it, that was when I was like, wow, like pure maths is like, this is hard. Like, what is this?
That's exactly right.
It's like
yeah.
I have all the definitions, I have all like the theorems, whatever I need to use, but like when you get asked a question, you sort of have to like play around with things,
Yeah, you have to
get things together. It's like that's hard.
and then somehow use the right definition, the right time, in the right theorem, in the right order. Like, yeah, there's a lot of. It's kind of like solving puzzles. Like most questions you do in pure math, generally, if they're not like formulaic, are like solving puzzles. You have to play with a few results. I think what was the worst part of that course? Probably the exam. The exam was
Worth a lot
worth a lot.
and almost
Some of the
pretty
questions.
impossible.
Yeah, the questions in that exam were harder than the assignment questions. And mind you, we had like a week to do the assignments. So if your exam question is harder than the assignment question, something's not right.
Yeah, was it like 6 questions and
6
3
questions.
hours?
Yeah,
Two-
that's right. Yeah, well, I guess 2.5 because you have to upload
Yeah.
the thing anyway. But
Yeah, so this is done at home. You had all the notes to your like
open book.
open
That's right.
book,
You would think
do whatever
easy,
you
no
want.
worries.
Yeah, but like that's really not how pure maths works. Like you can have all the definitions, everything, but if the question is hard and your brain doesn't get it, there's no chance. Like
There's no
you can
chance.
have like
That's
a whole
right.
week on it, you might not get it.
Yeah, there was like 2 questions in there which were like practically impossible.
Yep.
Yeah.
The last 2 questions,
Last 2 questions,
were worth
that's
10 marks each out of a 60-mark exam.
That's right.
Yep. And I don't think I got I think I got half a mark for the last question. I tried.
I got like 1 or something.
And I think the average.
I remember looking at the average because I remember like doing a Zoom meeting or whatever with the lecturer, and he showed you, and it was like the average mark was like 0.67 out of 10. And I'm like, holy moly! Nobody got it.
No one got that question. Like, I just felt like. Yeah, and imagine that's like 10 marks from a 60-mark exam. That's pretty it's pretty detrimental to your grade. And the exam was worth like 70%, 60%?
60-70%, yeah.
Yeah, like that's rough. So, yeah, although I enjoyed the course, the sort of mark definitely left a bitter taste in my mouth.
Yeah, that definitely, when I look back at it, makes me slightly bitter about it. I think I'm saying, like, that was my worst grade, that course. Which is sad because it was a good course.
It was a good course.
But it's just
just ended on
a bad note. Yeah, that's right. And then also, I think we had lockdown or something. So the exam got delayed. You remember that?
Oh, yeah.
That's right. We had like an extra 7 days to study.
Reschedule. Yeah.
I'm like, wow, that's good. I kind of needed it, but in the end,
it didn't matter.
It didn't matter. Yeah. I'm like, there's no chance I could have got those questions.
Yeah.
And so then there's not much to say about the numerical methods course. I don't think
it was just like hands-on. Here's how you discretize things.
Yeah, like you solved a few ODEs. Yeah, that's right. Numerical. That's exactly right.
That was the whole
we did some integration, a few methods like Simpson's rule, trapezoidal rule, whatever. Yeah.
And we didn't even get to like Monte Carlo, which was like a bit unfortunate. But I thought
that's right. Yeah, the course finished like a bit too early. Yeah.
What did the course finish on? Like some stiff ODE solving.
That's right.
Yeah, use different
like time varying ODE solvers where that's right. Like some parts of your solution might be changing rapidly, so you can't be using
do more time.
Time intervals.
Adaptive time stepping.
That's right. Yeah, but virtually,
it was okay.
Yeah, it was okay.
It was hands on.
It wasn't good by any means, but it was okay.
It was okay.
Yeah. But the physics courses were
do EM?
Those were dark times.
Those physics courses were
So EM, the biggest criticism in that one was this course because they introduced index notation.
Yep.
But we had already done index notation in our multivariable calculus course, and so you're just wasting time.
Yep.
He's going through like main results. We've seen them all. And that was like weeks on end.
It was like 2-3 weeks.
Of just the index
9
notation.
lectures of index notation.
Because I'm sure there probably were people in there who hadn't done it before, but like you look at the course on the website,
the
prerequisite. Multivariable calculus. And you're like, what are we doing?
Yeah, so you really
like the only difference was you're calculating triple integrals and line integrals in the context of EM.
In the context of EM.
But you're fundamentally just doing MCC, like multivariable calculus again. Yep. You're doing it all again.
Yep. It just comes down to writing the triple integral. Now that you're not given it, you write it.
You write it down. That's right. Yeah, you use a bit.
But it's not even that hard because there's like 2-3 equations. That's like the main.
That's exactly right. Yeah. So that was probably the worst thing about it. It was just.
Yeah, it was a rehash.
It was a complete rehash. It was pretty much good for nothing.
You wonder. That's when.
I don't know how they let that slip through. Like.
Yep.
They're obviously not talking.
There's no communication
whatsoever between them because that was a complete waste of time.
And you find this is like a common theme. Like courses don't talk to each other. They don't seem to know what you're doing.
That's right.
And then
that's right.
It's just like it's messy.
But classical physics.
That was
this was the low.
Maximum sadness.
This was sadness maximized. That's right. Holy moly! Oh man! I mean, where do we even start? I mean, first.
Did we do any more tip and slip?
No, I don't think so.
Okay.
Actually,
yeah, I don't think we did, which is good because we did too much of that already.
We did plenty of tip and slip
in first year. Start of second year. Oh no. Oh, did we? I don't remember actually.
Yeah, but to summarize classical mechanics, the second semester, that one is basically, what was it like? You just there's no setup, there's no like, we're going to be talking about this today and for what reason. It was just like, here's this problem and here's like some equation we need to solve. And then he would just be up there for a 50-minute lecture solving the problem in every single bit of detail.
Solving the problem
like
as in...
rearranging the equation, doing all the nitty-gritty substitutions, like, and you sit there and like... 5 whiteboards of like whatever working out later, you get an answer, and then you just like, this is it. Physics. And you're like, what was I supposed to get from that? And that was the same thing. As soon as he's done with that, he says, all right, now let's do this.
Yeah.
Like, so basically we solved, like, I think one of the first things we did, or kind of early on, was the oscillator, right? This is the one that sticks out in my head. It was like, you just solve the oscillator by itself.
Yeah.
And then what do you do? Then you put a damping, and then you make the thing move, and then you do the same working out.
More terms.
That's right.
You're literally solving the same D over and over again, just with an extra term, but he goes through the same detail every time.
Every time. And then you just like, what was I supposed to get out of this? Why should I care?
Yeah, like,
and
literally,
that was the biggest, like the best instance of like absolutely not motivating anything whatsoever.
Yeah.
It was just like
maths for the
presenting maths at you, watching them do the maths, and then struggling to figure out what was going on.
Yeah.
And that was pretty much the whole course.
Yep. Like, to me, it's not important how you solve the D. I mean, presumably, it's not even that hard to solve the D. Like, it's literally just basic rearranging.
That's why you take a DE's course,
yeah,
right?
that's why we have
the whole point is to take the DE's course.
Like, that was the point. We had to solve DEs. The whole point of a physics course is, like, explain to me what this means in terms of the physical context.
That's right.
In terms of, like...
Give me some intuition.
Yeah.
Give me some intuition, please. Like...
And the solution, what does this solution mean? Like, how can I physically think about this? What we just did on the white, like, there's no
and sure, they would talk about that, but it'd be like the quickest tack on. It's like 2 minutes to go before the lecture finishes, and he whacks up a plot and then talks about it for a minute, and that's all he does.
It's like, see you next week for another DE, guys. Yeah.
It was just...
It was that weeks on end. Like, we did so much of
most of the course, yeah. Like...
and then we did some orbital mechanics. Oh, that was so sad as well. Orbital mechanics, like right at the end.
Oh, that's right. Yeah, jeez.
It's like, here's Kepler's laws. I don't even remember what we.
One of the main things we did. What was that thing? There was an application with the.
Some like we boost into another orbit or something.
That's right. Like you go at like the. I can't even remember, to be honest. Like that. Talk about bitter taste in your mouth. That was it. Like I can't even look back at that course without being sad. Like because it was just such a waste of time.
Orbital transfer.
Yes, Holman.
Holman orbit. Wasn't there another one?
There was another one, but it was like a slingshot or something.
Or something, yeah.
Whatever it was. Jeez. Oh my goodness.
Man. Yeah.
Yeah, there
was. Like you'd think that's such cool topic to talk about, right? Like you'd think, wow, like how do rockets, calculate how fast they need to go to like get into their orbit of another planet or something. But like I don't know, it was just done in the most dry, just pure math. Like rigor, not even like it was just like rearranging stuff like that. I don't even see
like
any of that.
Introduce like some random parameter using the solution.
There were so many random.
And then just like, okay, this DE is a bit too hard to solve, so let's just assume this is really, really small. Yeah. And then you just see all of these like really less than signs or greater than signs, and then they're like
stuff vanishes.
Yeah, that's right. Do this magic play, and then you get some answer. Then
a key thing is like something we notice is like the way lecturers explain things. They know the answer already before they tell it to you. So the way they explain it is so like just random. It just seems so random to you. Like it doesn't make sense how you would ever think about that and the whole thing is because they already know the answer. All they do is like, trust me, I'll show you this. And I'll prove it to you afterwards.
That's exactly
Don't ask me how I got it.
Yeah.
Because I already know the answer. I'll show you that it works.
That's right. Yeah, this is like whatever it's called, like the trial solution method, right? It's kind of like they know the answer, they put it in, they say, okay, we're going to be testing this to show that it solves the D. Let's say there's a D and they say, look at this function. Let's plug it in and see if it solves the D. And then, what do you know? It solves it. But then you're like, how am I supposed to develop intuition when you're just like, just starting with the answer and then showing with how it works, right? There's no like, maybe if we do this, like they don't ask questions. It's just like
they don't tell you
plow ahead. Like, what do you want from me?
So all you really do is you get this trial solution and you see it works, but then you get nothing out of it because of course it was going to work because you already knew it was going to work.
That's right.
But how would you ever develop the thinking to actually think about these problems?
That's right.
We weren't ever taught that. So.
That's right. Yeah, so that's when I realized my physical intuition was like really low, like in some of those shoots, because I was like struggling to even figure out what was going on because we had only been doing like maths, like learning how to solve different equations. But then, when you come across a question which asks you for setting up problems.
Oh yeah, completely no clue.
You have absolutely no idea because they do it all. They do it all, but they don't explain how their thought process.
Because
that's right.
They don't even do it anymore. They just know the answer.
That's right, and that what's the word, apathy they have for teaching. Yep. They just didn't care. That was the course which epitomized that, them not caring. Yep. And I was like, man, that was low. Yeah, I was like, so this is the same time we both started a maths degree concurrently. Yeah, so this is originally we were enrolled in just a physics degree, but then we're like, all right, maths seems to be much better, so we enrolled for a maths degree. Yeah. So now we're doing a double degree.
Yeah, we're doing a double with pure maths.
But that was the semester which
that was a semester where we made the decision because we were like, wow, look, we like maths courses. Every time we have a physics course, it seems to not be so good.
It's sad. Yeah, that's right. And then you do a maths course, and then you're like, wow, this is not bad. So it's just it makes sense to do maths.
Yeah, it makes sense. And I guess we kept the physics because maybe third year, we still had a little bit of hope, I guess.
Tiny little bit. And also we're 2/3 in. Yeah. There's no point to why drop it down? We might as well just get it done. Yeah. So yeah, I guess now we're in our third year, or basically at the end of our third year. We're about to finish our third year. But yeah, so first semester, what did we have
semester? We did Physics 3, that big course.
Yeah.
We had a combination of quantum mechanics, statistical mechanics, and electromagnetism.
And they're all concurrent. They're all parallel.
Yeah.
That's right. You would have 2 lectures a week
on each topic.
On each topic. QM, 2 weeks, 2 lectures on StatMech, and 2 lectures on EM.
Yep.
That's right.
Yeah, so it sort of ran as 3 courses, but in hiding as 2 sort of thing.
Basically, yeah, it was a double unit course, but they crammed 3 in there.
Yeah. So it was a bit. That was pretty sad too, to be honest.
There was some. The worst one clearly was. Before we get to that, maybe the other 2 courses we did was a topology course.
And a groups and rings.
And course and groups and
rings.
More,
abstract algebra with focus on groups and rings. Yeah.
That's right. So let's start with best to worst. So I guess topology was my favorite course of all time so far.
I think mine was groups and rings. But
because algebra, the abstract algebra course we did in second year was very good, but this was just I guess the place where you saw lots of things all happening, and there was no rehash.
No rehash. Oh yeah,
virtually none. No rehash whatsoever, and that was a breath of fresh air to see that. What do? We did metric space theory, basic point set topology, Banach spaces / normed vector spaces, and then Hilbert spaces / inner product spaces. And it was just all of the results were pretty basic. I think the metric space theory was the chunkiest one. We got to some nice results there.
Yep.
Picard-Lindelof, which we saw the year before, and in the DE's course, when we had to apply it, and then you're like, what? What do you mean?
Oh, that's so funny.
But it's good to see, it was good to see in that course, why it made sense finally, what we were doing.
Yeah. If you want to see this proof, take topology next year.
That's right.
That was funny.
That's right, they did name drop it.
If you're interested to see this proof, go take this course.
That's right. Okay, yeah. No, definitely. There was actually not too many people in those courses though, from memory.
Probably a handful, 10, 15.
15 maybe. Yeah. It was pretty small. But yeah, so lots of new content, all interesting. The lecture was quite good too.
The lecture was really good. Yeah.
So yeah, I was pretty impressed with that course.
For sure. Yeah. I think I would have liked topology if I was better at analysis. I think if I was better at analysis, I think I would have liked it. By the end, it got really hard. I sort of knew how things worked, but when I tried to apply it, it was just not happening. It was hard. Yep. Although the exam was, I think, pretty generous. The
exam was, it wasn't by any means he wasn't copy and pasting questions, but there were all questions which we could do.
Pretty reasonable.
There were some tricky ones in there too. I remember maybe not finishing one.
One part of one question.
That's right. Yeah. But that's right. I think probably the most difficult thing for that was probably the group assignment.
The group assignment
was an introductory thing to the Zariski topology.
Yeah.
You just prove some basic results.
Yeah.
About it, but that was
that was hard.
That was pretty hard. Yeah.
Because we didn't really get taught about it. We just had to read some stuff and just figuring it out on our own, basically. It's
That's
like
right,
a
that's
recipes, like step-by-step guide through this
that's
through
right.
sketchball.
He broke all the proofs down,
Yep.
but it was still like
Pretty
seeing
hard.
the bigger picture was like
Yep.
pretty difficult.
Yep.
And in the end, I don't think they saw completely the bigger picture of what we
No,
had done.
no.
But
It has something to do with affine spaces, but
that's right. That's right. Yeah.
I still don't really see it, but it's alright.
To be fair, that was like right towards the end, and we're just immediately after that we started getting into exam study. So I'm like, there's no time.
No time to think about it.
Yeah.
But yeah, no, that was definitely a really good course. I think I definitely really like groups and rings more. I think I'm more an algebra person than an analysis person.
Sure. Yeah.
So groups and rings was just like an expand. Although I do think they spent a bit too long on groups because we presumably already did a lot of group stuff in algebra.
There was a fair bit of. I think my biggest complaint with that course was the rehash with the abstract algebra I did before. Like the first 3-4 weeks were like pretty much proving the same results. About groups, like normal subgroups, quotients of groups, and then we talked a little bit about products of groups and direct products and whatever. And it was just, but that was like we've seen a lot of those things.
I think the only reason I didn't really mind it was like I felt like I worked with these things more and got a deeper understanding of it.
Sure. Yeah.
And I was like, oh, like great.
Like the second time through, things were a bit clearer.
Yeah.
Sure. Yeah.
So I think I did. Yeah, I would have liked a bit more ring theory, but I mean, I didn't mind. I think I still enjoyed it nonetheless.
That's right. Yeah. I think. Yeah, the ring theory wasn't too bad, but it was just I kind of didn't see the point completely of rings because we just did kind of pretty basic examples.
We did like 4 weeks on it or something.
I think it was 4 weeks only. Yeah. It was
so
kind
I
of
don't think we had enough time to work with them.
That's right.
Yeah.
It was kind of just like a quick introduction of different kinds of domains, whatever. Integral domains and principal ideal domains and unique factorization domains but like just super quick.
Just like here's the definition, here it is.
But I guess the main result was that
you get
polynomials over a field can be uniquely factorized.
Yeah.
Like, or even better, every ideal is a principal ideal. Great.
Oh yeah. Yeah.
Not a bad course though. Not a bad course. Yeah. But yes, but the big chunky physics one was the worst. So there was, like I said, there was 3 parallel parts.
Yep.
The worst parallel part clearly was
StatMech.
StatMech. Yes, that's right. Absolute junk. It was absolutely terrible. Holy shit. The lecturer. Not naming any names, we can't do that. But my goodness, it would just be like a Zoom call. And he would just sit there reading the notes out to you.
He would it was an audiobook.
Yeah, literally.
StatMech, the audiobook. He would annotate the notes.
The
notes were already written. It was based off a textbook, so I don't even think it was I don't think it was original.
No.
He was just reading it to you, and maybe here and then he would give you a bit more information about beyond what the paragraph already said.
That's right. Yeah.
So
but only if you ask the question. They're that's it. But there was, at the end there was 4 people rocking up to those Zoom lectures.
Lectures anymore
because they were so bad. It was ridiculous. It was ridiculous.
And following on from what classical physics was just pure just math and math and more math. StatMech was that and probably worse.
Yeah. The fact that he was reading off the math.
He was reading math.
There would be 2 pages of just basically doing products rules and chain rules, and he would read them out to you and underline them. And you're like, really? Where's the physics? Where's the physics?
Yeah.
And there was no flow. He would present examples, but they would be completely not connected. And they would be just dropped in the middle of a lecture and you just didn't get anything out of them.
It's why are we doing this again? It's because the curriculum needs you to learn this. So
that's right.
That's why it's here.
That's right. It's
not
just
because it makes sense or anything, just because they need you to learn it.
Yeah, and it's just basically the same problem with the classical physics course we did. It's just not motivating. You just sit there. He starts talking about a problem, does a lot of math, and spends a minute or 2 talking about some physics.
Yep.
And then that's when my intuitions just starts getting worse and worse because I'm just not getting better at it.
Getting trained.
You're not training them, training us. Yeah.
Stat Mech was sad.
But yeah, so that basically the sadness followed on, permeated down through classical physics to Stat Mech. Yeah.
Yep.
The next, electromagnetism. Okay, not bad.
Not bad.
I didn't mind it.
I didn't. It was weird how we learned all this index notation, and then suddenly we did use a single time index notation.
That was probably the most bizarre thing.
That was
about
really
it.
bizarre.
Yeah. You spent basically a whole semester learning index notation for electromagnetism, and then not to use it.
And then to not use it once. Yep. Not even at all. It was really weird.
But I guess what did we do? I guess we saw the most interesting part was probably the electrodynamics at the end.
Yeah, I like the wave.
Yeah, that's right. Yeah. It was cool to see the wave equation. It was cool to see Maxwell's time-dependent equations. But yeah, it wasn't terrible, and the lecture also wasn't terrible.
Yeah, I think the only thing I would say was the index notation was just weird.
That's right. Yeah. It was okay again. Yeah.
It was not bad.
Yeah.
And then what did we do in quantum mechanics?
The problem with quantum mechanics.
The whole thing was doing
It was in two parts. The first part was rehash of what we had done, maybe in slightly more detail. Mm-hmm. So, for instance, when you solved the harmonic oscillator, you introduced these Hermite polynomials.
Oh yeah.
And you're okay, that's cool.
I've seen this.
You've seen them now. That's right. But you've basically the first you did infinite square whirl, you did the harmonic oscillator, you did some tutorial questions about them.
Yep.
That was the first 4 weeks, and then the grind.
And then
you're solving the hydrogen atom in spherical coordinates.
Yep.
They spend a bit too much time on the math. You spend 4 lectures or something watching him derive the Laplacian in spherical coordinates,
which we've seen how many times? 4 times.
Because in in second year electromagnetism, we did the same. Yep. In multivariable calculus, we saw the derivation again in spherical coordinates. Even more in multivariable calculus, you saw the general form for all of the differential operators, and then you just have to sit there wasting time again. What are we deriving this again for? We've seen it 4 times now. That was so the derivation for the solution for the sphere for the hydrogen atom was really long-winded.
That was pretty long. Yeah. I guess by that time though, anytime I see some sort of derivation or math about to happen, I just turn my brain off. I just got used to it.
Not worth and then every now and again if he does some funny trick or something, you just pay attention.
Pay attention.
But if he's sitting there for half an hour doing algebra on the board,
you just turn your brain off.
You just switch off.
There's really no point.
Why bother? Why bother? So that was, I guess it was okay. I mean, one of the weird things, but even when we solved the hydrogen atom, at the end we started doing some dodgy stuff, which I didn't quite appreciate. Because at least if we're going to spend this much time doing it, let's at least do it properly. But then they start taking shortcuts. I'm like, well, what's the point? But it wasn't terrible either. It wasn't a terrible course. Yeah.
I think Stat Mech was definitely
that was dark.
Yeah.
So that semester wasn't terrible.
It was stressful though, because technically we had 5 courses to study for. Topology was really hard.
Topology was a hard course.
We spent so much time studying that.
That's right.
And there was 3 physics courses to worry about, which is not fun.
That's right.
Yeah. So I guess in terms of stress, I was definitely more stressed last semester.
That was a stressful semester. There was definitely a lot of work to get through because how many lectures? Geez, you got to watch how many hours of lectures?
So many
ridiculous.
Lectures. By the time you watch the lectures in a week, you have to assignments are due, tutorials you have to look at, and then by the time you do that, the next week's lectures are there. You have to start watching those, and the grind just never stops.
And then towards the end, we started getting group assignments for 2 of the maths courses.
That was so sad. That one day we left uni at
11 o'clock, 11:30.
That was so sad.
I was like, whoa. And we came in at 9.
We started at 9.
Because the group assignment was due the next day or something. And we're like, geez.
And we weren't even slacking. We literally
we spent every day of that week doing the assignment. We and our other group member was dead weight. Basically didn't come in once. Like he would come in, spend an hour and then sorry guys, I've got to leave. Good for nothing.
We weren't procrastinating, but there's just no time.
We were on top of it most of the way, and at least from what I've seen from other students is they generally fall behind. If I've seen anything, it's definitely You ask your average person, how many weeks behind you on lectures? Like 2, 3.
2, 3, yeah.
Yeah, like that's standard.
Yeah, everyone rocks up to tutorials. The first thing they say, I haven't watched the lectures this week. That's like the most common phrase.
The motto, that's right.
Like a canonical phrase. I haven't watched lectures this week, guys. Sorry.
Yeah, and that I definitely watch lectures. I'm not preparing for tutes anymore. I just don't have the time and the willpower either. Yeah. For maths, I'll prepare for maths, but I can't prepare for physics anymore. It's just it's just too much. It's too sad. And so now we're here in second semester, third year.
Yep.
And what are we taking now? We're taking a course in fields and modules.
Fields and modules?
Yeah, more quantum mechanics, fields and modules. We're taking a course in partial differential equations and special relativity and analytical mechanics. That's right.
Which I guess looking at the degree when I was in high school, this was like the semester I was the most looking forward to. Like when you read the course description, you're like, wow, you do like bracket notation, you do like tensor notation, the Lagrangian mechanics. You're like hearing these words, you're like, wow, music to my ears.
Find the holy grail, we made it. Like,
music to my ears.
This is it. Yeah. And then what? Guess what happens? You just get underwhelmed, like completely flat, just like balloon pops. Like, oh Jesus!
I guess by this time though, we're not even like the expectation is like 0. So like
that's right. Yeah,
it's not as painful.
Yep.
Not as heartbreaking.
No, it's definitely not as bad as second year, but it's still like
it's pretty sad. Yeah.
This could be done better, but it's not being done better. Yeah, basically. Yeah.
I guess it comes back to like motivation. It's like, why do we consider this? Why do we care? Why?
Precisely.
Yeah. Why is it this exact thing you're talking about? Why is it not some other thing?
That's right.
What was the thought process that led to the formulation of this exact thing? Like, G mu nu is not notationally convenient.
That's right.
But that was what it was not. First week?
First week, yeah. Like we're introducing the metric tensor G mu nu for notational convenience.
Like, but really is it? Like,
that's the essence of it. Like this is the point of this Minkowski space.
Like you're not working Euclidean space anymore. He didn't even say that. It's like we're not thinking in Euclidean space
like,
where the metric is just normal. You have the Pythagoras. You work.
That's right. That's right.
He didn't even say that.
No, not even that.
He literally didn't even say
just like straight in.
He's like, boom, Minkowski space-time. Look at this metric tensor. This is the notationally.
That's right. Here's the space-time interval. Here's the space-time diagram. And you're like,
this is time-like. This is space-like.
Oh, it was
this is a light cone.
Again, just jumping from thing to thing. No link and no motivation.
Yep.
And you're sitting there baffled every time.
Like half the battle, like not even half, like probably 80% of the battle is like working out what actually, like all the stuff behind what he says.
That's right.
Because the maths is like, it ends up being trivial, right? Like it's not even hard.
Yes, if you have some idea about what's going on, the maths becomes trivial. That's right. That's why this is the thing that annoys me the most. If there's anything, just spend time getting physical intuition.
Explain physics.
Like, get the physics.
Yeah.
And then the maths becomes easy.
The maths
like if you know the maths, because let's say you've done DE's course, you've done a course and maybe a bit of group theory, etc., you'll be fine. Mm-hmm. But if you don't have the physical intuition, you will struggle.
Yeah,
you will,
especially if we're in 4D space with weird
That's
relativistic stuff happening.
That's right.
There's no chance I can write down a single equation.
And that's the thing, yeah. And the other thing is, there's virtually no questions being done. Him explaining, like the lecturer explaining,
right,
like concepts,
like
that.
Examples,
like,
right?
Examples, yeah. Kind of just
all
like
theory.
Does a quick proof, quote unquote, of a theorem, quote unquote, and then it moves on. That's it. And then you get to the tute, and you're just like, oh wow, I can't even set up one problem.
Yeah, that was in relativistic mechanics. That's
right. Yeah.
Yeah, I couldn't set up a single problem. Like they just made zero sense.
But
then you go to the tute, you see the maths, you're like, wow, this is so trivial. Like what is going on? Like why were we not explained?
That's right. Yeah.
How to set up the question rather than writing it and then telling us how to solve it, because we know how to solve these.
That's right. Yeah,
it's
like
not even hard.
Don't bother anymore with all of these math steps. Like we're definitely capable of this now, especially when it's this basic. Like when you see the calculation being done, you're like, wow, that was trivial.
Yeah, like think of like year 12 stuff basically, but like slightly more complicated.
That's right.
It's literally the same.
Same thing though. Yeah. But it's just more layers to pierce through. That's basically the only thing. But if you don't have the intuition, you can't pierce through the layers to get the light. You can't see it.
To the physics, you can't get to it. Yeah. I guess we're doing classical mechanics. I mean, Lagrangian mechanics now, which is a bit better. Because at least if it tells you, ball rolls down a slope, you're like, great, I can think about that.
That's right. And you have some idea how to set up the coordinates.
Yep.
You have a much better picture.
Yeah. I'm not minding analytical mechanics right now.
Nah, me neither, to be honest. I think just this is where, like I said, the maths becomes important, but we're not even at that level. So basically, the physics now requires such high level math. Like, it's not even such high level math, but if you've done any amount of postgraduate mathematics and probably beyond, you'll be fine. But when you're an undergraduate and they're doing like functional analysis in physics lecture and he's doing a proof, again, quote unquote, you're just sitting there like shocked and you don't understand anything.
But somehow it's like useful for like physics. But like,
that's right.
I'm surprised, like, because like compared to our classmates who are doing physics, we probably have the most maths like background. Because if they're doing like a single physics degree, they wouldn't have done as much maths.
No, that's right.
And even like when we look at the maths, it's like, what is going on? This is like postgrad maths.
That's right.
Like we haven't seen any of this yet. So like when he shows it to us, like he thinks we know it, or like, you know, he just says, "Oh, you guys know about manifolds?" It's like, no, we don't.
Yes, that's right. We haven't done differential geometry. Thanks. Yeah.
Don't worry. This is just some weird, obscure mathematics. But
that's right. Yeah.
I'll show you how it works.
And then he just continues to play away, and you're like, really? Is that necessary? You're like,
it almost seems like condescending. It's like, do you know about functional analysis?
Yeah, that's right. Like, you're stupid. Not good enough. Yeah.
Yeah, pretty much. Like,
yeah. But yeah, basically, if to summarize, you've obviously, anybody listening has picked up the pattern. It's just not enough motivation and emphasizing the wrong thing.
Yep.
Like, that's just basically been the thing through and through.
Yep. And very apparent in physics courses.
That's right.
That we've done. Yeah.
That's right. Oh, I didn't mention the maths courses, but I think the partial differential equations courses,
okay.
Not much to say there.
It's sort of like your DE's course in second year.
Except,
it's a bit more complicated.
Yeah, that's right. And at least you're doing more computer stuff, which is necessary. So you
see some cool things, I guess.
Every now and again, that's right. Yeah, they pop up, which is quite good. But yeah, Field Engineering Modules course that we're taking now is also pretty good. It's split up into half field theory, half module theory. Yeah.
Yeah. No, I like the field theory part. That was good.
That was cool. Yeah.
Modules are hard, but
that was like introduction to Galois theory. That was really cool. Yeah.
We saw the...
You see that cool, you know, when is a polynomial solvable by radicals, you finally learn the magical condition for when it is solvable. Yep. So that's pretty cool.
Yep. Still getting through modules. Pretty hard, actually. Right. They're really abstract.
They're abstract.
Yeah, more abstract than I thought.
That's right. But at least doing the questions, you have a rough idea about what to do still, though.
Yeah.
Which is good. Yeah. But yeah, that's where we're at. What do we have another year to go after this? Yeah. Yep. And it'll I think mostly be maths.
Mostly be math. I think
next
we have
year.
two more physics courses to take, I think.
That's right, yeah.
Yeah. But they're not that bad, I'd hope, anyway. But I guess you'll
Let's hope so, yeah.
find out.
That's right. Forget hope. You can't hope anymore. Yeah, not after this many years. Yeah. But that's it, yeah. So
that's about it.
In hindsight, I guess the biggest takeaway is if you're interested in learning something, just read up on it on your own.
Yeah.
Like, of course, if you're that interested, go to uni and study it for sure. Because then you can, get a career out of it, work in the industry with it. But if there's anything that piques your interest, take the time to learn it in your own time. Yeah.
Like, I used to think, you go to high school, you learn stuff, you find out what you like. You go to uni, you learn it to the peak, you become a god at it.
That's right. The biggest brain ever. Like, pure knowledge comes through.
And then you finish uni and you do a PhD with this big brain knowledge and you do some crazy research and that's it.
That's right.
But you do uni and you're like, wow, this is not even close to what it's like in the real world.
No, you're
just getting started.
You're still just getting started. Yeah, you haven't even got through the basics yet.
Yeah, you're still learning the basics.
Yeah. At least with maths, you're still learning the basics. I think with physics, you're still, let's say, you're a little bit on a higher level, but your maths is still not on the basics. Close. So that means you're still going to have a hard time. Yeah, so there's definitely more road to travel even after undergraduate.
Sure. The road is long.
Does not stop there.
Yeah.
So if there's anything that interests anybody, just
go out there and
do it. Yeah.
Don't wait for the learning. I think that was like a mindset.
And don't expect it to be given to you either.
Yeah, for sure. Like
that's probably one of the biggest things I've learned. Yeah.
Definitely. Like I used to think, lecturers will give me the good stuff. I'll just take it and learn it. But really, it starts with you. Like you go and when you work with the material, that's when you do the learning.
That's when it happens.
No one gives it to you.
That's right.
You internalize it, it becomes yours.
That's right.
I think that's the important thing. Yeah.
Yeah, well said. I think that's pretty much it. So those are the biggest takeaways from being in uni so far.
Yeah. I guess you'll hear more from us in the future about maybe more courses if we decide to do a recap on this again after our whole undergrad.
That's right.
Or like after
what's the step after this, whatever. I guess there's I doubt much will change, to be honest, in the next year, to be honest. Like I feel like
I'm not gonna be like, wow, I take back everything.
There's virtually no chance, unless I have some like magic breakthrough moment, but I'm not expecting that. I guess
that's basically it from us.
I'd say so, yeah.
And stay tuned to hear from Tom and potentially a special guest. To
shout him out? I don't know.
Yeah,
I think he introduced himself.
He introduced himself.
He'll introduce himself,
Yeah, but basically we have a new member. And I think we're going to try with different groups from now on. So like maybe next week we'll have different combinations of people. Or maybe we do all four again.
Sure, yeah.
Could be cool. But we were just experimenting.
Different ideas, yeah. But this was just, I guess, all right. See ya.
Thanks, guys. See ya.